sp2 again. sp2 again. So 3 hybrid orbitals. It is 2 sigma bonds, 2 sigma and 2 pi bonds. Therefore sp hybridization, 2 hybrid orbitals. It is also sp, 2 hybrid orbitals. Now total number of hybridized orbitals. Hybrid total how many? 4 plus 3, 7, 9, 12, 12 plus 4, 16 hybrid orbitals. Next, number of pure orbitals. Number of pure equal to number of hydrogen atoms or heteroatoms. Heteroatoms plus 2 into number of pi bonds. 2 into number of pi bonds. This is number of pure orbitals. Now count the number of hydrogen atoms. Number of hydrogen atoms are 3, 1, 1, 1. So 3 plus 1, 4, 5, 6. 6 hydrogen atoms plus 2 into number of pi bonds. 1, 2, 3, 4. So total 8 plus 6, 14 pure orbitals. Like that they are framing questions. Okay, yeah. Now I want to discuss about here. See, number of hybrid and pure orbitals of benzene. Benzene. The formula of benzene: CH double bond, CH single bond, CH double bond, CH single bond, CH double bond, CH. Now every carbon is sp2. It is also sp2. So 3 hybrid orbitals. 3 hybrid orbitals, 3 into, how many hybrid orbitals are there? 6 carbons, 18 hybrid. And number of pure orbitals, number of pure equal to, count the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, plus 2 into number of pi bonds, 3. Sorry, I wrote wrongly. This is having alternate single and double bonds. Okay, 3 pi bonds. So 6 plus 6, 12 pure orbitals. Pure ratio of hybrid and pure, 18 is to 12, 3 is to 2. Like that we have to approach. This is the state of carbon in organic compounds. Understood all of you? Yeah. Now I want to discuss about bond line notation. Bond line notation. How to write the organic compounds in different forms. First, bond line notation. Second, condensed form, condensed. And third, expanded form, expanded. And fourth one, three-dimensional, 3D picture. So first, bond line notation. Bond line notation. For example, if I am saying CH3, CH double bond, CH single bond, CH3. How to write its bond line notation? You write every carbon, you write it as a dot connected by another carbon having double bond. Again another carbon connected by CH3. This is called bond line notation. For example, if you are having a CH3, COOH is there. How to write its bond line notation? Because in organic chemistry, in all competitive exams, they are giving bond line notations only. They are not giving clear picture. Therefore, here how many carbons? 2 carbons, first carbon. Right? This is actually first carbon. It is second carbon. Okay, I am writing first carbon here, connected by oxygen and OH. Oxygen means carbon tetravalency. Carbon is having tetravalency, means it had satisfy 4 bonds. So double bond O connected by single bond OH. That's it. For example, this is called bond line notation. For example, if I am saying CH3, CH2, COO, COO, C2H5. How to write its bond line notation? Count the number of carbons from here 1, 2, 3. So 1, 2, 3. Right. Okay. Yeah. Now, first I wrote these carbons. After that, this carbon connected by oxygen, double bond O, and single bond O. Next, C2H5 can be written as 1 and 2 carbons. This is bond line notation of ester. Bond line notation of ester. Right? Yeah. Now, yes, Kari Karuna, what you are saying, Amma? AP EAMCET Telugu medium? Chand sir. What is that meaning? I didn't understand, Amma. Okay. Now, this is the bond line notation of this ester. Now, how to write the bond line notation? How to write the bond line notation of C6H5 COOH, like that. Whenever they used a word C6H5 benzene ring, write alternate double bonds. Now connected by C. Again double bond O, single bond OH. This is bond line notation of benzoic acid. Now I want to discuss about, this is bond line notation, condensed formula. Condensed formula. For example, if I am saying N-butane, N-butane, isobutane, isobutane, neopentane, neopentane, isooctane, isooctane. What is the meaning of iso? What is the meaning of N? What do you mean by neo? Listen properly. First N-butane, condensed formula means CH3, CH2, CH2, CH3. This is called condensed formula. Iso, same butane, if you are writing a branch, if you are writing a branch like this, then we can write it as isobutane, condensed formula CH3, CH, inside the bracket CH3, CH3. It is a condensed formula. Here only I want to say expanded formula. Expanded formula means C, H, 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 C. This is called expanded formula. Expanded formula. Okay, like that you write remaining. Now I want to say neo and iso. What is the meaning of iso? Octanol. Iso. The meaning of iso, branch, branch at extreme, branching, branching at opposite terminal. Opposite terminal is called isooctanol. First you write octanol. 1, 2, 3, 4, 5, 6, 7, 8. OH. 1, 2, 3, 4, 5, 6, 7, 8. It is called N-octanol. N-octanol. I want to write isooctanol. Whenever I am using a word iso, branching, branching means that 1. This is the branching. This is 1, 2, 3, 4, 5, 6, 7. This is branching. This is called isooctanol. Isooctanol. Numbering is given from here. This is called sixth position. Methyl is there. You can write it as 6-methyl. 6-methyl heptanol. Heptanol 1. First place OH. This is called isooctanol. Next. What do you mean by neo? Neo means two branches. Two branches. Branches at extreme right. Extreme opposite. Opposite terminal. Now I am saying neo. Neo-octanoic acid. Neo-octanoic acid. So first 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Double bond O, OH. Right? 1, 2, 3, 4, 5, 6, 7, 8. Whenever I am using a word, you have to remove the two carbons. Make it as two branches. So, how to write that? See, 1, 2. This is called neo. Okay? Double bond O, single bond OH. 1, 2, 3, 4, 5, 6. So, 5 comma, this is called 5 comma 5. 5 comma 5. Dimethyl. Dimethyl hexanoic acid. Hexanoic acid. Common name neo-octanoic acid. Neo-octanoic acid. Iso means not same. Iso means in organic chemistry. Venugopal, listen properly. Iso means branching at extreme opposite terminal is called iso. Done. That is over. Now I want to discuss about this is neopentanol. Now I want to say primary, secondary, tertiary. Yeah. For example, if OH group attached to a carbon which is attached by no other carbons, primary, or if OH group attached to a carbon, if OH group is attached to a carbon which in turn attached by one more carbon, it is also primary. Next, secondary. What is the meaning of secondary? If OH group attached to OH or any group, OH or any group, so attached to a carbon, this carbon again attached by two other carbons. This is secondary. Exception. Exception for propanol means secondary and isopropanol both are same. Propanol same only. If you consider secondary butanol and isobutanol, they are not same. Why? Because secondary butanol means a carbon connected by OH which is attached by two more carbon is called secondary. Iso means OH attached to a carbon which in turn attached by other carbons. This is called iso. Isobutanol. Secondary butanol. Like that. Tertiary butanol. 3-degree butanol. What is the meaning of 3-degree? If OH or any group, halogen, attached to a carbon which in turn attached by three more carbons is called tertiary. Tertiary. Now, like that, you have to understand types of carbons, right? Yeah. Now, I want to discuss about this is about types of carbon, state of carbon. I want to discuss about condensed formula over, right? Expanded formula over. Now, compressed, what is that? Bond line notation over. Now, three-dimensional. For example, if a carbon attached by chlorine, bromine, bromine, then attached by OH, and again attached by hydrogen. How to convert this three-dimensional into two-dimensional? Three-dimensional into two-dimensional. Yeah. Who is observing you? OH is observing you. You can hold with your hand. You can hold. So first you write carbon. Carbon. Now this carbon connected by OH. So you write OH this side and you write chlorine above. Write bromine down. This side hydrogen. This is the conversion of three-dimensional into two-dimensional. Now see this kind of arrangement. How it is converting three-dimensional into two-dimensional. Okay, listen my dear students properly. This is the carbon attached by four different groups or atoms. How to convert this three-dimensional into two-dimensional. Okay, yeah. Now, something is happening. 1 minute. Yeah. Now, yes. Now see my dear students. This is the compound. Here red ball is, listen properly. Here, yeah, like this. Yellow ball is OH, right? Yellow ball is OH. This red ball is chlorine. This is blue ball. Now to how to convert this compound into two-dimensional, right? Who is observing you? Yellow ball observing you. Yellow ball observing you. Yellow is called OH. Yellow is called OH, right? Yeah. This is white. Hydrogen is white atom. This is chlorine. Red color is chlorine. And this is bromine. Blue is in bromine. Blue colored atom. Now, how to convert this three-dimensional into two-dimensional? Who is observing you? OH is observing you. Observing you. Right? You hold this. You turn like this. Then you keep everything like this. This is called Fisher projection formula. Conversion of 3D into 2D. Anything, whatever group is in dark line, that is observing you. dash line, it is away from you. So who is observing you? OH. Turn like this. Then flat. This is called conversion of 3D into 2D. Understood? Tell me all of you. Chlorine is red. OH observing you. H away from you. Who is observing you? OH. Now you are holding, turning, then keeping like this. Understood? This is the conversion of 3D into 2D. Like that. OH I will keep here. H writing here. Br down. Cl up. Red. So red is up. Who is down? Blue. Understood? Tell me all of you. Saileja, Sai Teja, Narasimha, understood? 3D into 2D. This is 3D into 2D. Okay, next. If you have given a compound like this, hydrogen, OH, this is CH3, chlorine, bromine, this is CH3. How to convert this into two-dimensional? How to convert this compound into two-dimensional? Same thing. Feel this is the OH observing you. Hydrogen away from you. It is observing you. Observing you. So this is the, write this dot first. Dot. Who is there above? CH3. And who is there this side? OH. You can hold OH. Turn like this. Turn like this. So OH will come here. Now hydrogen will come here. Now we write the next carbon. Next. Now who is observing you? Who is observing you? Bromine. Now bromine you can hold with your hand, turn like this. Bromine turn like this. So you write bromine here. Write chlorine here. Down methyl. This is the conversion of three-dimensional into two-dimensional. Understood all of you? Okay? Yeah. So this is about the conversion of three-dimensional to two-dimensional. Okay? I am writing another picture now. Another picture. This is COOH. This is Cl. This is Br. This is OH. OH. And this side methyl. And another compound here attached by fluorine. It is again attached by NH2 group. NH2 group. Now this is connected by CHO. How to convert this compound into two-dimensional? Right, understood? Now first you write this is the junction. Junction. Who is there above? COOH. Who is observing you? Who is observing you? Bromine. Who is away from you? Chlorine. Turn like this. Who is observing you? Bromine. Turn like this. So Br here, chlorine here. Next, this is the next junction. Now who is observing you? Who is observing you? Methyl. Right, methyl. Who is away from you? OH. Understood? Next, who is here? NH2. Who is observing you? Who is observing you? NH2. Who is observing you? NH2. Write NH2 this side. Who is away from you? Fluorine. Down you write down CHO. That's it. Conversion of 3D into 2-dimensional. Okay? Anything. Whatever compound is given, you can easily write 3D into 2D. Then you can say RS configuration. That we'll discuss later. Understood? Yeah. COOH is up. Okay, it is up. It is down. It is up. These are junctions. These are chiral carbons. Junctions means chiral. Chiral or chiral. Okay, this is called conversion. Different forms of carbons. Okay, yeah. Now I want to discuss about, already I discussed about homologous series. What do you mean by homologous series? Homologous series means series of compounds having same general formula. Series of compounds with same general formula. For example, CnH2n plus 2, alkanes. CnH2n plus 1, COOH. These are carboxylic acid. In this case, N will start from 1, 2, 3. Here N will start from 0, 1, 2, 3, so on. Now, if you write alkane, first you write CH4, C2H6, C3H8, like that. These two are differ by CH2. And if you write N is equal to 0, you only get only HCOOH and CH3COOH. These two are differ by CH2. So, such kind of arrangement are called homologous series. Based on homologous series, how questions are asking? Listen. Benzene and toluene. These two are examples of what? Isomers. They are not isomers, but they are homologous series. Why? Here already hydrogen is there. Here CH3. Differ by CH2. Differ by molecular weight. 14. They are called homologous series. If I am writing another compound like this, CH2, CH3. Now these two are homologous series. These two are homologous series. So all these homologous series are having nearly same chemical properties, but differ in the physical property. Molecular weight differ by 14 because carbon 12 plus 2, 14. Okay. Yeah. Similar chemical properties. Nearly similar. Nearly similar. Not exactly. Almost. But different physical properties. Now I want to discuss about next concept, habituation Classification of organic compounds, different types, right? They are saturated, unsaturated. Saturated means all our single bonds are called saturated. If carbon, any double bond is there, it is called unsaturated. Unsaturated. If any triple bond is there, also unsaturated. Exception. Exception. In case of benzene, there are 3 pi bonds. Still, it is saturated. Why? Because bromine in carbon tetrachloride, no reaction. No reaction. And Bayer's reagent, 1% alkaline, 1% alkaline, potassium permanganate, no reaction. Therefore, benzene, even though three pi bonds are present, continuously circulating around the carbon, so it is called saturated. Exception. Now, I want to discuss about saturated, unsaturated, right? Yeah, next one, homocyclic and heterocyclic. Homocyclic and heterocyclic. Heterocyclic. Right. Homocyclic means all are carbons only. All are carbons. Right. Heterocyclic means any another atom in the middle. We can call it as heterocyclic. Right. In this also, homocyclic aromatic, heterocyclic aromatic. First, we should know what is the meaning of aromaticity. Aromaticity. Aromaticity means the compound has to satisfy Haeckel's rule. Aromaticity. Best books for EAMCET for chemistry, and please give me chemistry reading tips. Very simple, Nandu. You join in our group WhatsApp. We'll give you all suggestions. Right now I am not deviating from class. Right? If you want, you can text me 9002000003. Right? It is chemistry group number. Roots Academy chemistry group. Roots Academy. Roots Academy. Chemistry group number. Chemistry group. WhatsApp group. You can ask any doubts in this group. Okay? Yeah. Now I want to go ahead for what is the meaning of aromaticity? Right? Anti-aromaticity. Now only I will teach. Why? Because when we are saying about the stability of carbocation, you have to know what is aromaticity and what is anti-aromaticity. Otherwise, you cannot understand keto-enol tautomerism. Understood? Yeah. Now listen, what is Haeckel rule? Yeah. Haeckel rule means every aromatic compound must contain, first rule, first condition, it must be planar. It is also planar. Second, must contain conjugation. Conjugation or conjugation with heterocyclic, like this. Conjugation with heterocyclic atom, heteroatom having lone pair. Having lone pair. It is another condition. Right? Anti-aromaticity. Also conjugation. It also must be conjugation. And third condition here. Here I want to write the third condition. What is the third condition here? all atoms must be sp2 hybridization. Here also all atoms must be sp2 hybridization. Fourth condition, all atoms must be, all atoms must be, can you increase the speed of explanation concepts? Yes, now see here, all atoms must be sp2 hybridization, it is also sp2 hybridization. Now, it must satisfy Huckel's rule, means 4n plus 2 equal to pi electron. N value must be 0, 1, 2, 3, so on. Here, it must satisfy Huckel's rule. 4n is equal to pi electron. N value 1, 2, 3. Like that. These conditions must be there in aromaticity and anti-aromaticity. For example, if you consider, this is the compound, we have to test whether it is aromatic or not. So all carbons are in conjugation. 4n plus 2 equal to 6 pi electrons. Because this is a pi bond, sigma pi bond. So pi bond with pi electrons. So 4n is equal to 4, n is equal to 1, aromatic. If we consider a compound like this, oxygen, having 2 lone pairs, whether it is aromatic or not. It is aromatic. Some of you are asking, sir, 2 lone pairs are there. So these two are involving in resonance. No. Here, if you consider the picture of this O, right? One lone pair is parallel to ring. Other lone pair is perpendicular to ring. These are only participating in resonance. So 4n plus 2 is equal to 1, 2, 3, 4, 5, 6 only. These should not count. So it is 4n is equal to 4, n is equal to 1. It is aromatic. Similarly, if a compound is having linked by nitrogen, right, nitrogen, double bond, whether it is aromatic or not, it is aromatic. Why? Here lone pairs present on nitrogen. These are parallel to benzene ring. Parallel because sp2 hybridization trigonal planar geometry. sp2 hybridization means trigonal planar geometry. Therefore, sp2. Whenever electrons are parallel to benzene ring, not participating in resonance. So 4n plus 2 equal to 6. N is equal to 1. Aromatic. Similarly, whether the compound is aromatic or not, cyclopropenyl carbocation, 4n plus 2 equal to sp2 hybridization. It is sp2. 2. 4n is equal to 0, n is equal to 0, aromatic. Similarly, if a compound is given like this, positive, like this, this is also sp2. It is also sp2. So, these are involved in resonance. 4n plus 2 equal to 2 electrons. And 4n is equal to 0, n equal to 0, aromatic. Tropylium carbocation. 4n plus 2 equal to 6, n is equal to 1, aromatic. Similarly, if you are considering, cyclo, octa, cyclo, octa, tetra, ene. Whether it is aromatic or non-aromatic or anti-aromatic. Whenever more than 6 carbons, more than 7 carbons, folding takes place. Folding happen. So its shape will convert into tub shape like this. Tub shape means it is non-planar like this, folding. They are not in same plane. All are non-planar. So it is not applying for 4n plus 2 equal to pi electron formula and 4n equal to pi electron formula. Therefore, it is considering as non-aromatic. Non-aromatic. Understood? Next, if the same compound are given like this, this is EAMCET 2014 question. EAMCET 2014 question like this. Whether it is aromatic or not, it's a question. In this case, folding is not possible. Folding of ring not possible, because these electrons will come, these electrons will go, these electrons will come. Immediately it will happen like this. These will come negative charge, right? This negative charge, this will come here, this will come here, another negative charge, right? Like that it will happen continuously. Therefore it is this ring is not for 1 minute, please. I am confusing what is happening. See, not like this. If these pi electrons are coming, negative charge, these are coming here. Immediately they will come. Immediately this will go. Immediately this will go. Immediately this will go. So this compound picture will become like this. Double bond will come. Okay. This pi bond will go here. This pi bond will go. This will come here. 1 minute. I am confusing. Just a minute. Here, these two pi electrons are present here. Then what is happening? If these pi electrons are coming here, negative charge. These are coming here. Okay. No, not like that. Here what is happening, I will tell you. Not like that. Look, if these electrons, if these electrons are coming here, right? Positive charge will come. This will come. Then it will happen, these electrons will come. Like this it will happen. Yeah. Like this it will happen. If these electrons are coming here, negative charge will come. Right? Again this will come. So continuously you are getting a negative charge like this. Therefore ring folding is not happening. Therefore 4n plus 2 equal to 10 electrons. 4n is equal to 8. N is equal to 2. Aromatic. Understood? All of you. Next, another one. If you consider a compound like this, positive, it is also continuously not folding. Ring is not folding. So 4n plus 2 equal to 6. N is equal to 1. Aromatic. Like that, we can discuss about aromaticity. Aromaticity. Now, I will discuss about if a compound is having a picture like this. 4n plus 2 equal to 4. N is equal to 1 by 2. So, it is not aromatic. Apply another one. 4n is equal to 4. N is equal to 1. Yeah. It is anti-aromatic. Anti-aromatic. Done. Like that, you can apply aromaticity. If a compound is having a picture like this is which kind of compound? Aromatic or anti-aromatic? Here, this is sp2 hybridization. It is also sp2, also sp2, sp2. It is sp3, sp3. Whenever sp3 hybridized carbons are present, we should not apply 4n plus 2 equal to 5 electron. 4n formula also we should not apply. So it is considering as non-aromatic. Non-aromatic. Okay. Yeah. Now this is about this aromaticity and non-aromaticity. Now I want to discuss about next topic, isomerism. No, I'm sorry. Before going to that, I want to discuss about IUPAC nomenclature. IUPAC nomenclature. In IUPAC nomenclature, directly I want to discuss about the rules. Right? First rule, longest chain rule. Longest chain. For example, if you have given CH3, CH2, CH2, CH, C2H5, CH3. Which is a long chain? 1, 2, 3, 4, 5. Is it long chain? No. Yeah, annulenes, aromaticity, all those things, Abhirami, annulenes, edulenes, all those things we'll discuss. Yeah, aromatics and annulenes will discuss in benzene topic. Abhiram, benzene topic. Okay. Yeah, suffixes and prefixes. Yeah. Whenever IUPAC nomenclature we are discussing, we should know the meanings of three words. Root word, suffix and prefix. What do you mean by root word? Root word means one carbon means meth, like that. C2, eth. So, prop, but, pent, hex, hept, oct, nun, dec, undec, dodec, tridec, like that. C20, icoso, right? C30, triacont, C100, hecta. Like that we have to discuss. Now, suffix. Suffixes are mainly divided into two types. Primary suffix and secondary suffix. Secondary. Primary suffix. Priority order. Okay. Yeah, we'll give priority order. Now, see, primary suffix means nature of carbon. If carbon single bond, ane. Carbon double bond, ene. Carbon triple bond, ine. If double bond and C triple bond is there, ene. Like that. If two double bonds are present, diene. Secondary suffix. Secondary suffix indicate nature of functional group. Nature of functional group. Okay. For example, if you are having OH group is there, all. CHO is there, all. Double bond O, own. Oic acid, oil chloride, oil chloride, Cn is there, nitrile, nitrile, CONH2 is there, amide, amide. If C double bond O, OR, alkyl O8, ester. It is ester. Like that, there is a list is there. Everything I can't write now. Why? Because so much time consuming that you go through. Right? Now, what is the priority order of functional group? If you see the priority order of function, first COOH, next SO3H, as per NCRT. As per NCRT. Right? Yeah. COH, SO3H, acid chloride. Acid chloride. Next, ester, amide, amide. Next, nitrile, aldehyde, ketone, ketone, alcohols, amines, amines. And then alkenes, alkynes, alkanes. Like that, these are the main functional group. Right? The order, everything, carbylamine is NC. Yeah. NC is called carbylamine. Carbylamine. Okay. Yeah. Now, this is the main. Mainly, we have to memorize this. After that, now we'll discuss about secondary prefixes. Prefix. Primary and secondary. If you are having cyclo, this is called cyclopropyl, cyclobutyl, cyclopentyl, cyclohexyl, like that, prefixes. Secondary prefixes. There are many kind of secondary. Methyl, methyl is CH3, ethyl, propyl, propyl, isopropyl, isopropyl, like this, CH3, twice CH, or they are showing like this. This is isopropyl. Right. Next one, tertiary butyl. Tertiary butyl. Right. CH3, thrice C, means carbon connected by 4 carbons. It is tertiary butyl. Right. Next, like that, isobutyl. Isobutyl. This is called isobutyl. Secondary butyl. Already I said you. This is secondary butyl. Right? Like that, we have to memorize prefixes. Now, I want to discuss about IUPAC nomenclature. Now, if you have CH3, CH down C to H5, CH down C to H5, CH3. What is the root? What is the root word for this compound? Root word. Root word is equal to how much? See, 1, 2. There are 2 carbons. Again, 2 carbons. Now, if you see like this, only 4 carbons. If you see like this, there are 1, 2, 3, 4, 5, 6 carbons. So, 3, 4. 3, 4. Dimethyl. Dimethyl hexane. 3, 4 dimethyl hexane. That's it. Similarly, if you consider C3H7, CH3, double bond, CH3, C3H7. Whenever a compound is given like this, you write the expanded form. Expanded form 1, 2, 3, CH3, double bond, CH3, 1, 2, 3. Now numbering is giving like this. 4, 5. 4, 5. Dimethyl. 4-octene. 4, 5 dimethyl 4-octene. Done. This is the longest chain rule. Okay. Now I will discuss about least sum rule. Least sum rule. Least sum rule. There are exceptions are there. In that least sum rule also exceptions are there. Yeah. Now first one I want to discuss about if a compound is given like this. Main functional group. Whenever main functional group is present, numbering is given from this side only. This is a long chain. So 4, 5 dimethyl hexanol. Okay. OH is called ol. Now, if you are having a compound, ring compound is present. Ring compound with functional group as functional group. I am saying about third rule. Ring compound with functional group having carbon separately named. For example, if the compound is there like this, if a compound is there like this, if a compound is there like this, how to write the namings? Whenever ring is there outside the functional group, this ring is considering as a branch. So this is called cyclopentyl. This is called carbonitrile. Whenever outside the carbon is there, directly attached. If this compound is having one more carbon connected by CN, then how to write its naming? Connected by CN, right? So 1, 2. At second place cyclopentyl. So 2-cyclopentyl. So CN, ethane nitrile. Like that we have to approach. Similarly, this one, ring directly connected by carbon with functional group. This is called cyclohexane. Carboxylic acid. Now this is ester. It is ester. There are two carbons, ethyl. Now I am writing its name separately. Look here. CH2, CH3. This is called ethyl. This is cyclopentyl. Carboxylate. I am sorry, I went wrong here. I have to write another oxygen should be there here. Like this. Okay? Yeah. So, if another oxygen is there here, then what you will write now? Oxygen is there, CH2, CH3, ethyl, cyclopentyl, carboxylate. Next, another one. If you are having a carbon having functional group directly attached to the bark of tree like this, this is directly attached. 1, 2, 3, 4, 5, 6. So here directly attached means you should write the numbering like this. So 1, 2, 3, 4, 5, 6, 7. So this is considering as continuous chain. Whenever continuous chain is there, you have to cut down here. Therefore, this is writing like this: COOH, COOH, COOH. Now this is the main carbon chain. Sorry, this is the main carbon chain. Now 1, 2, 3, 4, 5. Now what I am saying, pentane, pentane, 1 comma 3 comma 5, 1 comma 3 comma 5, tricarboxylic acid, tricarboxylic acid. Okay, like that we have to approach. For example, if the carbon, if this COOH instead of COOH, if CN is there, carbonitrile, same compound. Instead of COH, CN. Instead of CHO, CN, CHO is there, carbaldehyde. Instead of CHO, if C double bond O NH2 is there, then we can call it as carboxamide. 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 Right. Instead of that, if any ester group is present, alkyl carboxylate. Carboxylate. Okay. Yeah. Now, based on that, we have to approach. Now, what I am saying now, listen, my dear students. If you are having a carbon linked by COH, now I want to write CHO. Now, it is connected by CH2, CH2, CHO. Again, now, in this case here, what is happening now? Here CH2, CH2, CHO. Here these are not directly attached. 1, 2, 3, 4, 5, 6, 7. Now, under this condition, what is happening now? This functional group is not directly attached. If it is not directly attached, then it is separately written as. What do you write it as? Aldomethyl. Aldomethyl. So, it is at which place? 4. So, 4 aldomethyl. 1, 2, 3, 4, 5, 6, 7. Heptane. Heptane. 1, comma 7. Diol. Heptane. 1, comma 7. Diol. Like that we have to write. Understood all of you? Yes. Now I want to discuss about this writing of some kind of compounds. Now I want to discuss about another rule. If a carbon chain is having a branch, this is long chain. It is also long chain. It is also long chain. Now this chain is having 2 branches. This chain is having 3 branches. It is preferred. So alphabetical order. This is ethyl. So numbering, you can give any side. Numbering is giving from either side. Therefore, 3-ethyl, 3-ethyl, 2, 4, dimethyl, dimethyl pentane, pentane. Similarly, if you consider a compound is given like this, whenever a branch having another branch, then its name is written inside the parenthesis. Its name is written inside the parenthesis bracket. So 1, 2, 3, 4, 5, 6, 7. At fourth place, again 1 dash, 2 dash, 3 dash. So it is written as, right, 4. Oh, first you write it as 2, 6 dimethyl. 2, 6 dimethyl. Dimethyl. Now 4. Keep the bracket. Now 1 dash, 2 dash, 2 dash methyl. 2 dash methyl propyl. Propyl. Long chain called heptane. Called heptane. Understood? Tell me all of you. Understanding? Yeah. This is another model. Now, I will discuss about if a carbon chain is there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if this, yeah. Now, 4 and 5, if you are giving numbering from 4 and 6, at fourth place, I will write a carbon connected by branch like this. At sixth place, again, I will write a carbon. I will write a carbon and then connected by carbons like this. Now, how to write its, no. I just want to change this pattern. This carbon I want to write here like this. Now, how to write its IUPAC nomenclature? Yeah, this is at fourth place there is a branch. 1, 2, 3, 4, 5, 6, 7, 8 only. No, this is the only long chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the long chain. It is also long chain. Now, under these conditions, which one we have to prefer? So, whenever a situation coming like this, then what we have to do? Look, this is having long chain with more number of carbons. This is preferred. Right. Otherwise, if you are having a carbons more are there, more, 1, means more extra carbons. More extra carbons are present here. In this case, if you consider like this, I want to write this picture another way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now here I want to write 4 carbons like this. At sixth place I want to write 4 carbons like this. Now numbering is giving from which side? This side. So if you are giving numbering 1, 2, 3, 4, 5, 6. 7, 6 comma 7. 1, 2, 3, 4, 5, 6 comma 7. Under this condition, what we have to give numbering? Now here 1 dash, 2 dash, 3 dash, 4 dash. Here 1 dash, 2 dash, 3 dash, 4 dash. So which one we should write first? This is butyl. It is also butyl. This is 1 dash butyl, 2 dash butyl. So here 5. No, I am writing this. This is butyl. It is also butyl. So what I am writing now? First I will write this one. 5. 1 dash methyl butyl. Methyl butyl. Again 6. 2 dash methyl butyl. Methyl butyl. So 11 carbons. Undecane. Undecane. Here I just confuse this compound. For that I want to remove this content. Because this pattern I didn't memorize actual formula. So this is okay. Like this we have to write the nomenclature. Now, yeah, this is about the naming of saturated compounds having a branch with another branch. Now I want to see, look here, I want to do another naming. What is that? If a carbon compound is having HCOOH, this is called methanoic acid. Methanoic acid. If I am saying HC, right, double bond O, Cl, then what is its IUPAC naming? Or, I am sorry, I want to write like this again. Cl, C double bond OH. If I am saying HC double bond OH, this is called methanol. Based on that, many students will write this one, chloromethanol. Chloromethanol. No. You take its mirror image, Cl, double bond OH. Take its mirror image, H, C double bond O, Cl. Instead of this OH, HC double bond O, OH. Instead of this OH, we are writing chlorine. So this is called methanoyl chloride. Methanoyl chloride. Like that we have to approach. Okay, next. Now, if I am saying a compound having like this, this is the compound. Then what is the IUPAC name of this compound? Whenever this is called amide, amide. So here it is cyclopropyl. Cyclopropyl. Whenever in NH2 replacement of hydrogen, then we should mention N. So N cyclopropyl. N cyclopropyl. This is cyclopropane. Cyclopropane. Carboxamide. Carboxamide. Understood? Like that we have to approach. Okay? Yeah. Now listen. Listen, my dear students. Now I am saying about another kind of naming. For example, if the compound is given like this, COOH, this is O, C double bond O, CH3, and this side CH2, C double bond O, OH. How to write the IUPAC nomenclature of this kind of compound? Listen very properly. you take this compound CH3 C double bond O C double bond O OH. This is called ethanoic acid. Ethanoic acid. If you are taking CH3 C double bond O Cl, this is called ethanoyl chloride. Ethanoyl chloride. Like that, if you consider this CH3 C double bond O, this is ethanoyl oxy. Ethanoyl oxy. Therefore, this is ethanoyl oxy. This is considering as carboxymethyl. Carboxymethyl. Therefore, now when we are writing this numbering is giving like this. Therefore, IUPAC name of this compound is 3 ethanoyl oxy, and 5 carboxymethyl cyclohexane, carboxylic acid. This is IUPAC nomenclature of this kind of compound. Okay. Yeah. Now what I am going to say, when we are writing this IUPAC namings, IUPAC namings of alkene. Whenever you are writing the IUPAC naming of alkene, if alkene and alkyne both are at terminal, priority order 1, 2, 3, 4. So numbering is giving from here. So if more than one double bond is present, then we can use a word a. So 1, 2, 3, 4. So what we are saying now? 1 buta, 1 butane, 3 ine, or buta, 1 ene, 3 ine. Like that we can approach. If the compound having double bond is there in the middle, triple bond is at terminal, then triple bond priority. So 1, 2, 3, 4, 5, 6. This is the IUPAC naming of unsaturated compound. So here this is 1, 2, 3, 4, 5, 6. Now what we are writing now? 6 carbons. Right? Hexa, 4 ene, 1 ine. Like that we have to approach. For example, if the compound is having double bond like this and a triple bond like this, right? And in the middle we are having a double bonds like this. Now from which side we start giving numbering? From this side. 1, 2, 3, 4, 5, 6, 7. This side or this side? This side we should give priority. 8 and 9. This is taken as a branch. Therefore, under this condition, what we are doing now? Under this condition, so 7 ethynyl. 7 ethynyl. So This is how many 9 carbons are there, right? 1 comma 3 comma 5 comma 8. Nona tetraene. Tetraene 1 2 3 4. This is another kind of naming. Like that, we can write the IUPAC namings of organic compounds. Functional group priority. If more than one function group is there, we discussed about the order. Based on the order, we can write namings. Now, IUPAC namings of ring compounds. Ring compound. For example, if you are having a chain linked by a ring. Now, how many carbons here? Outside 3 carbons. Ring is having 3 carbons. If the number of carbons in the ring and chain are same, ring is preferred. So this is taken as propyl, cyclopropane. Similarly, if the number of carbons are more, here 1, 2, 3, right? 1, 2, 3, 4. So this is 1 cyclopropyl. Here chain is preferred. 1 cyclopropyl butane. Now listen. If the compound is having benzene ring, another side cyclohexyl. Now which is preferred? Benzene ring is preferred. So cyclohexyl benzene. Like that we have to approach for ring compounds. For example, if the compound is given like this, numbering is giving from here 1, 2, 3, 4. These are ethyls. This is cyclopropyl. Now cyclo C is considering as alphabetical order. This is ethyl. So what I am saying now, 3 cyclopropyl. This is ethyl. 1 comma 1, 2 comma 4 tetraethyl. How many carbons now? 4 carbons. Cyclobutane. Like that we have to approach. IUPAC nomenclature. Similarly, if the rings are jointed like this, 1, 2, 3, 4. Again 1 dash, 2 dash, 3 dash, 4 dash, 1 double dash, 2 double dash, 3 double dash, 4 double dash. Now, where the rings are jointed here, these two are joining. So, under these conditions, tomorrow, Abhiram, tomorrow also public live. Now listen, my dear students, what is happening now? Yeah, see here, 1 dash, 2 dash, one double dash, ter, cyclobutane, right? Yeah, if you consider phenyl ring like this, these are combined. One, this is 1 dash, 2 dash, 3 dash, 4 dash, 1 double dash. Now 1 comma, 1 dash comma, 4 dash comma, 1 double dash, ter, phenyl, terphenyl. Understood? Similarly, now IUPAC naming of aromatic compounds, it is IUPAC name is benzene or cyclohexane 1 comma 1 comma 3 comma 5 triene. Okay, now if you are seeing, this is 1. If you are seeing benzene ring, if the benzene ring connected by one functional group, then it is called phenol. If the benzene ring connected by more than one functional group, then this is the derivative of benzene. So 1 comma 2 dihydroxy benzene. Okay, yeah. Now if the benzene ring is connected by a carbon having OH, now benzene ring is taken as a branch. So it is only one carbon. So phenyl, methanol. If the benzene ring is connected by COOH, we will call it as benzoic acid. If the benzene ring is connected by CH2COOH, 1, 2. So 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. Likewise, you can easily benzyl alcohol. Where is benzyl alcohol? That is common name. Benzyl alcohol is common name. Common name, not IUPAC. It is not IUPAC. Okay? Yeah. Now, like this, you have to approach benzene ring compounds. So, like that, if there are two benzene rings are connected. Now, I want to discuss about the IUPAC naming of bicyclo compounds. Bicyclo compound. It is called bicyclo. Whenever bicyclo compounds are given, then you have to follow like this. Destination and location. This is your location. It is destination. So, when you are going from your location to destination and your location. When you are traveling, it is a junction, another junction. So, bicyclo, junction, two junctions, comma, again from here, two junctions, comma, from here to here, one junction, 1. Count number of carbons, 1, 2, 3, 4, 5, 6, 7. Heptane. Vatama, heptane, because 7 carbon. 7 carbon. If the same compound is given like this, then same thing. What is that? Numbering is always 1, 1, 2, 3, 4, 5, 6, 7. So, bicyclo, right? 2 comma, 2 comma, 1, right? 7, 7, 7, heptanone, heptanone. Therefore, this is just a small example of bicyclo compound. So, remaining so many examples are there. Tomorrow I will discuss. Yeah. Once again I am saying you, my dear students, many of you are having problem with organic chemistry. I will give you clear picture of full organic chemistry. Right. Those who are interested, please join. Right? Organic chemistry. Only for organic chemistry. If you are giving interest, we'll make it for only for organic chemistry. Only organic chemistry. Only organic chemistry. We can make it for 1,000 rupees up to NEET. This organic chemistry we are finishing mostly in 10 days. 10 days or 15 days. If 10 days means per day 2 classes. 15 days means alternate 2 classes per day. Okay? Everything I will explain. Okay? Yeah. Upala Sailaja, all of you, good evening. Right? Public live from tomorrow we are thinking because Abhiram, because we are taking public live, everything means whatever hard work we are doing, that is simply going. It has no use. So my request, better you join. Yeah, EAMCET, AP and AP EAMCET date announced now. When is your AP EAMCET, Amma? Jyoti, daily we have to practice organic chemistry. Jyoti, when is your EAMCET? Please tell me. Fast. When is TS EAMCET? Date. AP EAMCET date. Tell me all of you. Fast. AP EAMCET date. Announced no. Second week of September na. Jyoti, you are writing your exam in 2021 na. Okay, that is fine. Remaining students, TS EAMCET, August 24 confirmed. Uppala Sai Teja. TS EAMCET online. Online. Fast. Okay, 24th August onwards. Okay, in the meanwhile, we have to finish. First, we are finishing organic chemistry. September 3rd week. AP EAMCET, September 3rd week. Okay. That's why This is also question mark. It is okay. Okay. Okay, my dear students. We'll continue tomorrow. Okay. God bless you, my dear students. God bless you. Okay. We'll continue tomorrow.